Perplexity AI's best feature is that it cites its sources over the internet when you ask a question. But you couldn't get at those citations through the programmatic API. That's recently changed. Now, accessing it is very easy in some programming languages, and in others it's, well, not quite as easy, but it's still not complicated. It's straightforward. Let's take a look and see how it's done. Welcome to Tales from the Jar Side. Welcome. My name is Ken Kousen, and on the Tales from the Jar Side channel, I try to give you expert advice on how to code in languages like Java, Groovy, Kotlin, using the Spring Framework, AI, and so on. Let's take a look at the Perplexity AI API. Now, I did a video on this recently, and in that video, we talked about how they use the OpenAI API, and therefore it was very simple to access. But if you take a look at this page, this is the change log at the Perplexity API. They point out how just last week, they have now announced the public availability of Citations in the Perplexity API. Effective immediately, all API users will see citations returned as part of their request by default. You don't have to use some parameter, which they used to have available, called return citations. That no longer has an effect, and it wasn't enabled anyway. Unfortunately, this doesn't tell you how to get them or any detail. There's not much there. So it's a bit of an issue. If I go to Quick Start, then you scroll down and they have an example in Python that basically shows that yes, indeed, they are using the OpenAI library. So it's a Python library that was already created by the OpenAI people, the source of tools like ChatGPT and so on. All you have to do is put in your own API key and change the base URL to api.perplexity.ai, and you could ask a question using one of their supported models, all based on Llama 3.1 at the moment, and get a response and everything works. But let's take a look at that for a moment inside Python. So I basically added that Python script in here inside of PyCharm. The only thing I did a little differently is rather than hard code in an API key, I'm using the OS import here so that I could use getenv and retrieve my API key as an environment variable. This is exactly the example they were suggesting. It says, as a system message, you are an artificial intelligence assistant and you need to engage in a helpful, detailed, polite conversation with the user. Okay. And the user message is how many stars are in the universe. Fine. So I go ahead and instantiate the OpenAI class with the Perplexity API key and their base URL and use their Sonar small model, putting in the messages, and let's take a look at the response. Now, if you take a look at the response, it's fairly involved. We'll take a look at the details in a moment, but you can see that if you dig in, eventually you get a chat completion message with the content, and there's the content. But here's the interesting part now. You see how they have a square bracket 2 here, or they have over here a square bracket 5 or a square bracket 1 or a square bracket 4. In other words, they have citations as footnotes. And if you look down at the bottom of the response, then after the usage block, they have a new block called Citations. And the Citations block consists of a list of URLs for the individual links that they cited for their sources. They don't have a number in there. It looks like the index is, they are in the order that they are cited. So 1, 2, 3, 4, 5 that way. But that's how they're being shown. Now, with that in mind, I could say, oh, okay, let's not print the response directly. Let's instead print the content, and then I'll print the citations by saying for each index and URL an enumeration of those citations starting at 1, because their enumerations or their footnotes were 1, 2, 3, 4, 5. Let's print those out. So let me rerun this. And now you see you get an output, no definitive answer, blah, 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 2 and 5. And here are the citations this way enumerated. 1, 2, 3, 4, 5. So in other words, in a language that has no strong typing, in a language like Python, which is dynamically typed and everything, then hey, there's just another field in the JSON structure. Just access it the way you'd access any other field, and you're good. And that would be fine if all you're going to do is use Python. I'm a Java developer. I want to use languages like Java or Kotlin or others, and I want to incorporate this functionality into existing systems, not just use Python exclusively. The problem with that is there's nothing in those APIs that know about citations. First of all, let me show you the quick demo of what was done in the previous video. Is that I used a tool called LangChain4j. And LangChain4j is a framework in Java that already has an OpenAI chat model builder available. So I just used their OpenAI chat model builder, and I changed the API key to the Perplexity one. I changed the base URL to the one Perplexity supports and put in one of the Perplexity model names. And then when I run generate with a string, I get back a string, or I could even go all out and do something similar to what they did, put in the system message and the user message and print out the finish reason and the metadata and all this stuff, and watch what happens when I do this. And it all works like a charm. You can see, yeah, it stopped at the appropriate time. There's no metadata. Here's the answer. Again, the answer's got the footnotes in it. But there's nothing for citations. I even see token usage at the bottom, but I can't modify the LangChain4j modeling that was done unless I want to dig into the library and put in pull requests and things like that. For all I know, they plan that in the future. But one of the nice features of all this is I was able to reuse one of their existing ones. What this means is if we want to add this capability to Java, we have to map it ourselves. It turns out that's not too bad, however. Let's take a look. Over here, what you see is the API reference inside of Perplexity. And in the chat completion section, you see there's only one endpoint. They don't generate images, they don't convert audio, they don't do anything like that. It's just chat. So they have one endpoint at /chat/completions. You have to put in your authorization and then your body, and you can see what the body looks like. You have to specify the model, you have to specify the messages array, you put in your max tokens if you want, or temperature, a few other fields. Now, some of these fields are part of the closed beta access. And even though I've applied for it, I haven't yet been admitted to the closed beta access. So I'm going to leave search domain filter, return images, return related questions. I'll leave all those out. Search recency filter, you could specify a time limit, but I'm not going to worry about it. A couple of standard ones, there's a streaming option. I'm not going to do any streaming, although that would work just fine, but I'm not going to do that. And these couple of penalty ones, which again, I don't really care about, so I'm going to leave those out as well. Also, you notice in the response, while it does tell you an ID and a model in this object, which is always chat.completion, they don't say anything in here about citations. So they haven't updated the API reference yet with the new field. So we still have to figure it out, and we just saw it in the Python one, so we know where it is, but it's not in the docs here. When you're going to map these things yourself, there's two steps you have to go through. One is you need to set up an HTTP library. You need a way to transmit requests to the endpoint and get back responses. You're treating this API like it's just another RESTful web service, because that's what it is. So we need a way to get data there and get it back. And then we need a JSON parser, a parser that can produce and parse JavaScript object notation. I'm going to use Google's Gson because it's simple. Figured what the heck. Now, the first step that I would have to follow here is I would have to take these input and output structures and convert them into Java records. I could do it. I've done it before, but we have an AI tool available. Might as well use it. Here's good old Perplexity. I'm using the Mac app. Figured what the heck, I'll ask it to do it. And I said, based on the structure of the input and output messages described on, and I gave it that link. After all, I know Perplexity can access the internet. For the Perplexity API, give me a set of Java records that map to both. And if you scroll down, you will see they gave me a big input record, which is called chat completion request and has a message, and several output records that are based on a chat completion response. Like, okay, let's work with that. So here I have made a Java class, which I called Perplexity Records. And I've embedded both inside here. There's the message record, which is used by both the input and the output. Messages either have the role of user or system or assistant, and the content is just text. In the chat completion request, I eliminated all those fields that aren't supported or not directly relevant to what we have. I am going to set several of them to defaults. You see I've added an overloaded constructor so that the max tokens is some reasonable limit. The temperature, the top P, the top K, and the stream, those are all set to the defaults that they had in the API. So that's fine. So I don't have to write out all those. All I need to do is give it a model and the messages. In the response, I have here the ID, the model, the created timestamp, the list of choices, the usage, and there it is, my list of string called citations. Still got the choice record, got the usage tokens. We're good. Now it's time to transmit that. Here I have a class called Perplexity Service. I have the constant for the base URL, and I use system.getM to retrieve my key. Also put in a logger in case I need it. And here's how I'm configuring Google's Gson. Now the key here is to set this field naming policy so that I can convert lowercase with underscores, or what they call snake case in the JSON data, into camel case in my Java code. Here's the only method I have. My chat method is going to take one of those requests and return a response. I start off by taking that request and serialize it to a string, to JSON string. Here I use my HTTP client's factory method, new HTTP client, inside a try with resources block, so I know it gets closed appropriately. I create the HTTP request using their little builder, append /chat completions onto the end of the URL. Here's my accept and my content type header. I'm transmitting JSON data. I'm getting back JSON data. It's good practice to say it. Here's the authorization part with the key in it. And I just say I'm posting the body. There we go. That's the entire request. I use the send method on the HTTP client to transmit the request and ask for the body back as a string. And that'll give me an instance of HTTP response. I'm going to log that just to make sure I see the citations block inside it, but I'm sure it'll be okay. I'll check that the status code was an okay. It's got to be a 200 or otherwise I'll throw an exception. And assuming it works, I'll take the body and use Gson to convert that body into a chat completion response. That's the deserialization part that inflates it back into an object. Now let's take a look at the test case so I can drive it. Neat little feature in JUnit 5, by the way. They have an annotation called enabled if environment variable. And I could say, go look and see if there's an environment variable called Perplexity API key, which matches any series of characters. And as long as that key is there, then we can go ahead and do this test, but otherwise skip this test. So that way you don't accidentally try to run it when you don't have a key. So I instantiate the service, and here I'm going to say, let's go all out. We'll do the example they did. I'll make a system message that is the one we just saw, and a user message, how many stars are in the sky or what have you. And now I can make my request with the model and those list of messages, and the rest I set as defaults. Go ahead and execute it, get back my response, assert it's not null. This process will drill down into the text that's part of the output message, what I want back. And then here I'll say, let's assert that those citations are not empty. And I'll use an old school for loop with an index just so I could print out the index 1, 2, 3, 4, 5 on all those URLs in the citations list. Let's take a look. Let's run this one. In my logger, I'm showing the response, and you can see all those fields, several of which I didn't bother mapping to, but the model's correct, the created timestamp's there, the usage block is there, and yes, indeed, there are the citations. So if you scroll down to the bottom here, I have written out the answer, and then there's that loop that prints the citations out one by one. So everything works exactly as advertised. It took me a little bit more effort because, again, my existing library doesn't know about this new field. And unlike in a language like Python, where I could just access another property, I can't do that in Java. Here you see how the steps work to go ahead and refine a program to simply transmit a request, get back a response, generate the JSON data needed for the request, and parse the data needed for the response. Once again, why do this in Java? Well, most of my existing code's in Java. I would like to be able to incorporate Perplexity's nice features into that code rather than having to worry about Python. In the end, all of these AI tools are just RESTful web services. And if there's one thing we know how to do programmatically these days, it's interact with RESTful web services. I hope you enjoyed that. There'll be other videos coming up in the future for other APIs. So please subscribe and enjoy Tales from the Jar Side. Take care.